Managing security is managing risk. That very important fundamental principle of security is what we're going to be covering in this week's lecture. The lecture is based on Chapter 2, Risk Management, which is part of the reading this week and is found in course materials. A very common security definition is that security ensures the confidentiality, integrity, and availability of information assets through the reasonable and appropriate application of administrative, technical, and physical controls as required by risk management. That is a great definition, and it pretty much sums up everything that we do as security professionals. However, it is not complete enough when we dive down deep into the topic of risk management. When that happens, this is a better definition. Now remember, I started out by saying that risk management and security management are essentially the same things. So here we have an expanded definition that I came up with based on my experience. The proper application of business risk mitigation tools, that's the proper application of tools and methods resulting in the implementation of security controls that, when operating properly, either alone or as part of a layered set of safeguards, mitigate business risk associated with an information system to a level acceptable to management. This must be done in a way that maintains the highest possible operational effectiveness of the personnel and processes using the systems protected by these controls. Simply, it is our job to reduce the probability that a threat agent will exploit a vulnerability and cause significant harm to the business or customers or other stakeholders. It isn't always easy to see how this applies when we are trying to manage an environment. It isn't always easy to use a long definition like this. In fact, it's almost never easy to use a long definition like this when we want to have a practical application of principles. So what we come up with are formulaic models like this. In this risk formula, which is pretty common, we take probability of occurrence and multiply it times business impact, and then we reduce that value by dividing it by our existing controls. So let's take a minute and look at this. Probability of occurrence traditionally includes threats times vulnerabilities. Your threats are those things that are trying to get to your stuff, and the vulnerabilities are the weaknesses that allow them to do that. Business impact is usually the short-term and long-term financial negative effect of an attack on your business. And controls are things like firewalls, policies, and logon, passwords and user IDs, those kinds of things, which help to prevent, to detect, and respond to events when they occur. This is pretty good, and as it applies in general. However, in my opinion, this one is better when it applies to human attacks. Note that probability of occurrence is expanded to include means, motive, and opportunity. This harkens back to my days as a military police investigator, where we always look for means, motive, and opportunity, just like all law enforcement personnel do today. Means is the skill set required. Could the person have possibly done something? Did they have the skill sets required to get into our network and to exploit the vulnerabilities that exist? Depending on the controls you have in place, means necessary to get to the target are going to increase. Motive. How badly does someone want to get to our stuff? So is it motivated by financial gain? if you're a small business and all you have is 50 customer credit cards in your database, motive's going to be pretty low. But if you're a large healthcare company and you have hundreds of thousands of customer identity data elements in your database, motive could get pretty high. In addition to financial motives, there are political motives, which in some cases can be even greater than any financial gain that the attacker might achieve. An opportunity are simply the vulnerabilities. What doors and windows have we left open on our network that will allow an attacker to get to the target? So risk management, like all security, is a process. It's a never-ending process. There is no way that you're ever going to be able to stand back and say, I'm done. There are different processes for accomplishing the same outcomes, which is mitigating risk to an acceptable level and keeping it there. This is just one approach. And it consists of 3 phases: assess, mitigate, and manage. You can think of these as milestones on a continuous journey. It begins with a risk assessment. The assessment helps us understand risk is calculated in the formula that we've seen in the previous slides. Understanding risk and the elements that contribute to it, we can make recommendations to management to mitigate risk where necessary. Finally, we manage our controls, monitoring and measuring to ensure expected risk mitigation results. You never just assume that what we've put in place is going to work. It rarely works exactly as we expected it to work. Sometimes it's better, sometimes it's worse. Periodically, we assess again to identify new threats, vulnerabilities, or other changes that increased our risk beyond the acceptable threshold. One thing to always remember: in security, nothing stays the same. Threats emerge every day. New technologies are implemented. Attackers find new ways and obtain new tools for circumventing traditional controls. So it's important to stay on top of that stuff, and it's important to integrate it into a continuous process. So the first milestone is assessment. In assessment, we have the following steps. System definition. So in almost every case, we're going to be looking at risk as it applies to a system. Systems, as you may recall from architecture design, a system is a collection of devices, end user devices, servers, printers, whatever else is necessary, that supports a specific business process. As we go through this slide presentation, we're going to be using an accounts receivable system for a fictional company. That doesn't mean that we don't do assessments also of the network at large. As you will see, that a system is always put within an existing security context. However, we're going to focus on a system risk assessment here because that is what is most likely to occur on a daily basis within your organization. Once we define the system, we have to identify the probable threats, what vulnerabilities might exist in general or associated with those threats. We need to determine how easy it is for a threat to move down a probable path from the outside or from inside our organization to reach the target. We have to do an impact analysis to determine the impact on the business. We have to calculate risk, and then we have to come up with a controls recommendation, which, along with the findings of our assessment, we have to present to management. So let's dig a little deeper into system definition. Systems consist of entry points, exit points, data channels, and untested data items. Entry methods are methods used by the server software to receive information. So it can be a desktop or a laptop, however a device receives data. Those mechanisms in the device that allow it to receive data, those are entry points. Exit points are points where data moves to other systems. So there are two types. Direct exit points provide data to other systems without any intermediate stages. Indirect exit points provide data to the direct exit points. Data channels are protocol-enabled pathways over which data travels between a device and other network-attached devices. It includes things like TCP and UDP sockets, remote procedure call endpoints, and named pipes. And untrusted data items are persistent entities that are often placed on your system in advance of an attack that are leveraged by an attacker to reach the next level or to facilitate the next level of an attack. Many attacks are done incrementally. So if we block one of those increments that allows the attacker to get closer to the target, we've blocked the attack. So how do we get this information? What are the sources that we can use to define a system? Well, hopefully there is existing documentation. That existing documentation consists of network diagrams, change management documentation, system design documents, and system build documents. However, as any of us who've been in this business for a while know, documents don't always truly reflect the state of the current system. This is why interviews are important. By having interviews with IT department personnel, we can identify the gaps between reality and what we have in our documentation. We can also use interviews to discuss how the systems work and what other systems are dependent upon the system that we're assessing by having interviews with the business users. When interviews aren't possible, we can use questionnaires, but to me, questionnaires are a final or last-ditch effort to try to get information from people. To help to encourage managers to allow you to have their employees for an interview and take them away from money-making activities, keep your interviews as short as possible, be prepared with your questions, and don't let the interviews drag on for an hour or 2 hours, because if you do, you're going to find yourself without anybody showing up for subsequent interviews. And finally, even though we trust the people that we're doing these assessments for, we also want to do our own scans. So once you gather all target system information, confirm with scans. Confirm that the server actually exists, or the device that you're looking at actually exists within the network, and security context described by the documentation and staff. We're going to talk about security context here in a couple more slides. For example, does a server actually sit in a restricted network segment, or is the data center set up as a flat network? We're going to take a look at network diagrams here in a couple minutes so that you can see the difference between a flat network and a segmented network. Scans can be automated or visual. The important thing here is that we confirm what we've been told and what we've read in documents by doing our own checks. And after a close review of all the information, we come up with this. This is a logic diagram, and you can make it any way you want. This is just my approach to a logic diagram. This is For those of you who've been database management for any length of time, will see that this is a data flow diagram. But the purpose of this is to be able to sit down with the business users and with IT, especially the business analysts, and confirm that we understand the way the system works and the way the different components interact with each other. It's important to do that, because if we've misunderstood, then that misunderstanding is going to filter through everything else we do, and our final recommendations are going to be off. So what are some of the things that we look at in a system when we're looking at the system definition logic diagram? Well, three of the most important things are authentication, authorization, and accountability. How do employees, services, and devices, which are subjects that are trying to access a resource, how do they verify their identities to the resource that they're trying to connect to? That resource they're trying to connect to is called an object. So we have subjects that access objects. And as an aside, remember, a subject can be an object at times too. It just depends on the context that we're looking at. So a subject is a subject is an entity attempting to gain access to a resource, an object. Authorization is the process of granting a subject a set of rights and permissions once it is authenticated. The primary outcomes of authorization are separation of duties, ensuring that no one person can perform all tasks associated with the business process, least privilege, ensuring subjects can only modify, add, or delete data as required by their roles, and accountability. How are we tracking who's doing what real time, and can we reconstruct an event, a security event or a risk event later to determine what happened, what should have happened, and how we prevent it from happening in the future during a root cause analysis. We also want to take a look at the attack surface. How are entry points, exit points, and data channels protected? And how do controls prevent, detect, or react to untrusted data items? So once we get a feel for how data flows through the system, it's important to understand what controls we have on that data flow. Our database server in our fictitious accounts receivable system does not exist in isolation. It's part of a system, which might be part of a network segment, which might be part of an enterprise network. And each of these infrastructures contributes to the server's overall security context. The overall risk of database server breach is the aggregate risk of that security context. Controls in place are missing at each of the layers represented in this slide, and there might be more or fewer layers in your organization. Determine overall risk. So this is an example of or this is a diagram that represents the network in our fictional company, or our fictional company. Note it is flat. It is not segmented. You will see the difference as we get to the solution diagram. In this diagram, we can identify two locations from which an attack might come, and that is from remote devices or from internal devices. It could be a rogue employee or an attacker who made it inside the company. The network diagram should track closely with the logic diagram that we saw a couple slides back. The difference between the two diagrams is how we perceive an attack path. The logic diagram depicts application modules and their relationships. The network diagram is better at showing the logical or physical path to the potential target. Before starting a controls analysis, it's helpful to base your assessment on a standard of best practice and any relevant regulatory requirements. This helps identify all possible challenges and demonstrates to management and auditors why you're recommending your mitigating controls. Two very important standards of best practice are COBIT from ISACA, ISACA.org, ISACA.org, and the ISO IEC 27002 standard from ISO. These two standards are used by security professionals, by the government, because the ISO 27002 standard of best practice tracks very closely with HIPAA. And COBIT is used by auditors when doing SOX audits and audits that are outside the realm of certification audits. Again, few systems operate in isolation. Most business systems receive data from upstream processes and send processed information to downstream processes, as shown in this slide. So systems in the data center support business processes. When a system fails, one or more processes are affected. In this example, if invoicing fails, the path from order processing to shipping will also fail, and it can fail completely if there are no manual workarounds available. And in many organizations that have been automated for years, those manual workarounds are no longer relevant, no longer up to date. Failure to ship means unhappy customers, and an important consideration when assessing business impact. And be sure to identify each process's maximum tolerable downtime. Remember, that's the amount of time a process can be down without causing irreparable harm to a business. It's very important, and it's not just the process that you're assessing at the moment, it is the processes dependent on it. So if the process you're looking at, invoicing, can be down for 2 days, but shipping can only be down for 4 hours, the maximum tolerable downtime for invoicing is the maximum tolerable downtime for shipping, or the lower of the two values. Business impact also depends on the sensitivity of the data affected by a breach or other security incident. Data sensitivity is measured by using a classification scheme similar to the one shown in this slide. This particular one may not work for your business, but that's not important. What is important is that you do classify the data in some way so that you can determine the sensitivity of the data, which also affects business impact, also affects the motivation of an attacker, and helps to determine the right level of risk. Some examples of restricted data are EPHI, or electronic protected health information, personally identifiable information, intellectual property, organization's financial information, network access and configuration information. One of the things that an attacker does prior to the actual penetration attempt is to map your network. Do not allow an attacker ease of access by taking all your network diagrams that you're not using one day and throwing them in the trash without shredding them or putting them in a secured trash container. And the organization structure. Social engineering depends to a large extent on understanding the organization's management hierarchy. The next step is threat identification. Threats are intentional or unintentional methods or events that might leverage one or more vulnerabilities. This table lists some common threat sources, motives, and agents. It's not a complete list, but it provides guidance on how to create your own. Note that for each threat source, there are multiple motivations and multiple threat agents or actions. We cannot assume that a terrorist, for example, is simply going to plant a bomb. There are other ways for a terrorist to achieve political ends. Next, we identify vulnerabilities. We discover network or system vulnerabilities in three ways: scanning, vendor notifications, and research into known vulnerabilities to the probable threats that we identified in the previous step. Scanning and vendor notifications are valuable when looking for known vulnerabilities and failures by the IT staff to follow best practices. However, they don't provide a complete picture when determining how likely it is that a specific threat agent or action will be successful. This is where research helps fill in the gaps. The table approach is a good way to demonstrate findings. However, it lacks the depth needed to apply existing controls to determine the actual risk of the vulnerabilities we found. This is a better way to do it. This is the beginning of a risk calculator that we will complete as we go through the rest of the slides. And as you can see, for each threat agent, there are multiple vulnerabilities possible. So for each threat source, there are multiple agents, and for each agent, there can be multiple vulnerabilities. You can see how this can get out of hand and why we try to focus on a system or device when we're doing a risk assessment. A good tool for a control analysis is the attack tree, and that's our next step, assessing the existing controls. An attack tree is a logical representation of the path, devices, and controls a threat agent or action must traverse on its way to the target. In this case, our target is the accounts receivable server. Before we continue, remember that this is a general approach used to determine the potential impact of existing or missing controls. We're not academics, we're security practitioners. The calculations that we use, that I'm going to try to step through and that are included in the chapter, in the reading, are just very basic. And it's just to give us an idea that's directionally accurate about what kind of risk we might be facing given the threat vulnerability pairs that we have created and the current state of our network. So the probability that an agent action can reach a target is calculated using skilled guesses, information gathered from the assessed threats, and a little probability theory. The boxes are organized in layers. You might do it differently, but we will use this approach for our example. Within each box, you see P equals some number. P represents probability, and N is the probability that an attacker will crack through the control device represented by the box, and it's represented as a fraction of 1. 1 equals 100%, and 0.5 equals 50%. The value of P is largely subjective. There are too many variables to calculate an accurate number. Therefore, we use our experience and information gathered in previous steps to make a scientific guess. Often, we do this by consulting with outside experts, when sometimes we don't have the skill sets in-house to make a close enough estimate. For each layer in this graphic, advancement to the next layer either requires a condition set and or a single or condition. For example, a remote hacker using the web server as a launching platform for her attack must pass through the internal firewall and compromise the web server and pass through the internal firewall. Based on current vulnerabilities, threat source motives, and existing controls, we estimate probabilities of 1 for firewall breach, probability of 0.5 for web server compromise. When all conditions must exist to move to the next layer, we calculate probability of success by multiplying the three values together. When we do that, the probability that an external attacker will reach the switch is 50%. If we remove the web server and assume a direct database connection attempt via TCP port 1433, which is wide open through the firewall, which is why the firewall is 100%, the probability of passing through this layer, the internal firewall, web server, and external firewall layer, increases to a 100% probability. The internal attacker on the right must gain physical access to the building and to an open active port. Based on our probability of success calculation, the probability of success is 50%. If a rogue employee attempts access, reaching the switch is 100% because they already have access to the network. Likewise, probability is 100% if an employee's system is owned by the attacker and controlled from a remote location. Owned means that the attacker has complete control of the system, usually without the knowledge of the user. Although there are no physical controls during the day at our fictional company, preventing physical access to a port, we assume that one or two employees are alert enough to ask about a stranger sitting in the conference room alone. So we're making the assumption that there's some security training and awareness activities going on in this organization. Passing through the switch has a 100% probability. The reason for that is because the switch is nothing more than a connectivity device at this point. It's not set up with access control lists, and it is not set up to segment the network. No networks. So at this point, we calculate each attack path separately. The remote attack path using the web server carries a 50% probability based on our previous calculation. Since the attacker must pass through the perimeter and the switch, the calculation is the 0.5 of our first layer times the 1 of the enterprise switch, which continues on with a 50% probability that the attacker can get from the outside through the internal firewall, web server, external firewall, through the enterprise switch, and reach the server. That's a 50%. So let's walk through this again. We had a 50% probability that the user can get through the internal firewall, web server, and external firewall. We arrived at that by multiplying 1 times 0.5 times 1. The attacker also has to get through the switch to get to the server. So remember, ands are multiplied. So we multiply the 0.5 from our first layer times the 1 of the enterprise switch to come up again with 50%. So now we have a 50% probability that the attacker is going to be able to reach the server. That's the overall probability at this point. So it's really a flip of the coin whether or not the attacker will get to your server or not. We can take two approaches to calculating probability for the final layer before the target, which is the operating system configuration and the database configuration. We can calculate probability for the path through each box, or calculate the layer probability and use it in our attack path calculation. To keep things simple, we'll use the latter approach. Our probability calculation changes this layer. Note that an attacker can decide to crack the operating system or the database instance, or both. When calculating AND conditions, you might remember we multiply. But when calculating OR conditions, we add. So the probability of passing through the operating system database layer is 0.6, which is the probability of getting through the OS. When calculating AND conditions, we multiply. When calculating OR conditions, we add. So the probability of passing through the operating system and database layer is 0.6 plus 0.6, which is 100%. It's 1.2, but the 0.2 is meaningless. So we know that from our previous calculation that the attacker reaching this layer has got a 50% probability of getting to that layer. That's 0.5. So we multiply the 0.5 times the 100% of the OS config and DB config, because you have to get through that layer as well as the enterprise switch, and we get 50%. So the P equal question mark at the target of the target is a 50%. So there's a 50% probability that an attacker either internally or externally can get to your server. I don't know about you, but that would scare the heck out of me. So before we move on to the next type of attack tree, I want to take a moment to look at component attack trees. And we're going to use the web server. So the question many of you probably have at this point is, well, how did you come up with 50% for the web server? Well, we did it like this. You can also do a component attack tree. Note that the web server has a relevant IIS vulnerability, and the probability of exploiting that is 100%. Is there sufficient attacker motivation? We know that getting to our accounts receivable server, it's going to be a highly motivated attacker. We're making that assumption. And to exploit that vulnerability does not require a lot of attacker skills. Note that we're using our risk formula, our second risk formula here, to help calculate the probability of compromise of the web server. So we know that we multiply AND relationships. So you have P, we have in the IIS vulnerability, that's 1 times the motivation times the attacker skills. We come up with 50%. Then we move up to a level called detection. In almost every case, we should make sure that we can detect anomalous behavior on our devices, especially those devices that are key to an attacker proceeding to the next level in our network. In our particular example, the company has no detection software, no monitoring setup, so it's 100% probability that the attacker can act undetected. So we multiply the 0.5 from the first level times the act undetected, which is 1, and we end up with a web server probability of compromise of 50%. This can be applied to a single application, to an application module. And there's another way to do this, especially at the module level, is to use an on-off attack tree. This is a lot faster, but it doesn't take in any shades of gray. It's just either yes, you can, or no, you can't. And that isn't always a good approach to take. But you'll have to make that decision based on the situation. In an on-off attack tree, it's very simple. There's no probability. You either can or can't reach the target. So if we remember that AND is a Boolean AND results in a 1 if all inputs are 1, and a 0 if in all other situations, then we can see that an input of a 0, a 1, and a 1 results in a 0. Which means that there's no way that the attacker can get to the web server at all, because the IIS vulnerability in this particular example does not exist. So if we use this attack tree and the relevant II vulnerability did exist, and we had 100%, and we did have the ability to get to the target, all we would have to do to stop the attacker in this scenario would be to patch the server. Next, we get to business impact analysis. Business impact analysis consists of multiple variables, and these are general variables. There might be different ones in your business. But again, we have maximum tolerable downtime, which is the longest time that a process can be down. And again, when we're assessing risk and we're assessing business continuity and disaster recovery, we're looking at processes, not servers. We're looking at the business process. What happens to the business process, and how do we recover that process if something happens? We looked at impact on employees, investors, and customers, and other stakeholders. We look at impact on current and future earnings potential, and we look at sanctions due to noncompliance with local, state, and federal regulations. There are two basic types of assessments. There's quantitative and qualitative. And I'm not going to go into a lot of detail on quantitative because it can be a little complicated for a slide presentation like this. But just leave it. I mean, if you want to know more about quantitative, read the material. The quantitative analysis actually uses dollar amounts. The problem is that it takes a lot longer, mostly because the numbers are not usually available. And the managers will not usually take the time to come up with those numbers. That's why we have to use the qualitative analysis. Honestly, I've never done a quantitative analysis. I've never been able to get managers to sit down or to dedicate resources to come up with the numbers. I've always done qualitative analysis, and it served me well, at least up till now. A qualitative analysis assigns numeric values based on employee or consultant experience and analysis of similar conditions and threats against the organization's industry. And even though you don't use dollar amounts, somehow you have to translate the result of a qualitative analysis into an annual loss expectancy. And as we're going to see here in a little while, average loss expectancy is what the business what is the business impact in dollars and cents from an event occurring. So if an event occurs, can it be expected to occur once every 3 years? The average loss expectancy is 0.30 of the total of the event. So if the total of the event is $10,000, but it only happens every 3 years, the average loss expectancy is $3,333.33. So before we move on to the calculator, I want to take a moment to look at the different columns that are going to be in the calculator. And the DREAD table, which stands for damage potential, reproducibility, exploitability, affected users, and discoverability, has been around for a long time. And I have modified it for the assessment approach that I've come up with. Because the previous DREAD table really wasn't applicable to how we apply risk management today, in my opinion. Reproducibility is the measure of how easy it is to circumvent a control. And if you can do it every time, there's no timing involved, there's no special conditions that have to exist before you can do that, then the rating is a 3, which means that it's a very high reproducibility rating. Exploitability is a measure of what kind of skill set the attacker needs to be able to exploit the vulnerability. Damage potential is how much damage there'll be to the business. This is also coupled with affected users to come up with business impact. So all users and key customers affected, some users, or very little impact on users or critical processes. Again, these are rather subjective, but you do have to sit down with the business users to come up with this information and your other IT peers. And discoverability goes to monitoring and log management. Can we detect an attempt, or either whether successful or unsuccessful, to exploit a vulnerability? And if we can, what is our response plan? Do we have one? Is it documented? And when do we practice it? So we put these into a risk calculator. And the risk calculator is just an Excel spreadsheet. And we multiply probability of occurrence times business impact. You can see that in the second row number 2. And that breaks down to reproducibility plus exploitability times damage potential plus affected users plus discoverability. Note that discoverability is part of business impact. because the sooner we can discover something that's going wrong, and the quicker we can respond to that, the lower will be the business impact. The resulting scores fall into these categories. So you have low risk, medium risk, and high risk. Normally, what we do is accept low risk and come up with solutions to mitigate medium risk and high risk while making sure that we put high risk mitigations at a higher priority. And then finally, we have controls recommendations. Controls recommendations are based on a risk calculation, and we have to begin to immediately plan for remediation. However, let's say we're in the middle of a budget year. How can we fix this without cash? Well, in this situation, there are usually controls to implement that cost nothing but employee hours, and we're going to see that here in a minute. So those are our first steps in risk mitigation. However, they're also part of an overall mitigation plan, incrementally implemented over 2 or more budget cycles. So this is important. We don't just jump in and start mitigation. We come up with a future state vision. Then we look at how we can get to that future state vision. Normally, that's going to be an incremental approach. Not often you can walk into a budget meeting and say, I need $2 million for security to mitigate this risk. It isn't going to happen in most cases. So what you have to do is show that you can get to you show the risk of the current state. You show how you can incrementally mitigate that risk over multiple budget cycles, and you put in a request for the budget for the current year while explaining or in setting some expectations for budget requests for subsequent years. So our future state for our fictitious company is here. If you'll notice, it is no longer a flat network. It is composed of security zones outward facing. It also has security zones in the form of VLANs on the inside. It has IPS layers, and it has access control lists implemented. So what can we do with what we already had without spending any money? Well, we could block all pet traffic passing through the firewalls and then open what is absolutely necessary and approved. You know, and when we first did our assessment on this company, the firewalls were wide open. So by following best practice and shutting down everything and only opening what's absolutely necessary, including leaving TCP port 1433, which is the Microsoft SQL database port, blocked on the firewall, we have reduced risk significantly. We create access control lists to restrict VLAN access. We bring patch levels up to date and require aggressive oversight of patch management. If no patch management process exists, it's not going to really matter how much other stuff you do. You have to have patch management. You must patch your endpoint devices. You disable all unused network jacks in the conference rooms, cubicles, and offices. This helps to prevent somebody from walking into your organization, even if they get past the security guard who happens to be out having a smoke at the time. They're going to have a very hard time finding a place to jack in where people aren't going to see them. Modify privileged account password management processes to ensure password policy compliance, and change the data center lock combination if it hasn't been changed in several years. So if we do all that, those are just the immediate remediation steps. You're going to see, and I haven't put it in the slides, but it's in the reading, that it significantly drops the probability of success in reaching the target. And it drops risk from 54 to 18 in our example. Again, these are the mitigate and manage steps. So once we come up with our our future state, we come up with an action plan. The action plan obviously is going to contain those things that we can actually do. Action plans are important. They have what it is you're going to do, who's responsible for completing it, and the projected date of completion and status. That is at a minimum. And then somebody needs to be responsible for managing the action plan. And then you implement the controls that have been approved by management, hopefully running them through an aggressive change management process. And then we manage and adjust, measure and adjust. Measure and adjust is not a big line item here, but it's very important. Again, in a world where everything works as expected, this wouldn't be necessary. But we haven't found that place yet. So we must monitor outcomes we expect from the changes we make. A good method is to pay a third party to conduct penetration tests and also to implement security information and event management within our organization. We can never assume that nothing has changed and the assessment, or that the assessment was 100% accurate. We have to watch, analyze, and manage the outcomes. Not the processes we put in place, but the outcomes. It's the same thing an auditor does. They're going to come in and they're going to check the outcomes expected by policy. And it's one thing that we did not discuss in this lecture, but I'm going to mention it now. Everything we do, all the outcomes that we try to achieve through risk management should be based on policy. Policy implemented at 3 different levels: at issue, system, and enterprise. And finally, when we present this to management, and remember, when you present your findings to management and your recommendations for mitigation, put it in terms that the managers understand. What's going to happen to the bottom line if we don't make these changes? Failure to do that will not get you very many budget dollars. Once you've done this, management can do one of 3 things. Well, actually one of 4. They can ignore what you've said, but most managers today aren't that naive. So there are 3 things that they can do. They can accept the risk. So I can almost guarantee you that if you go in there and show them the ease with which they can get to this fictional company's accounts receivable server, they're not going to accept the risk. That's assuming that they trust you and you haven't gone and you haven't cried wolf too often. But that's a whole other conversation. They can choose to mitigate the risk, which in this case would be our recommendation, or they can transfer the risk. Risk transfer is purchasing insurance to pay any fines, fees, or make up for any lost revenues based on an event. In a lot of cases, disaster recovery, you'll find that a lot of that risk is transferred. This is a risk decision flowchart that you can use for your presentation to management. It helps them to understand what you've tried to do and what decision you want them to make. One of the biggest mistakes that security professionals make when they walk in to do a presentation is not telling the managers up front what's expected of them at the meeting. I learned this the hard way many years ago. You walk in, you introduce the topic, and you tell the managers what your expectations of them are at the conclusion of the meeting. So in this case, you're walking in, you're presenting the results of the risk assessment. You're going to be presenting your recommendations for remediation, and you want their approval to proceed with their recommendation. Now they're in the right mindset. They know what you're asking for. And this particular chart is very important. It's a very important tool to insert somewhere early in the presentation so that they can see how you framed the conversation. Again, these are ways to measure and adjust with monitoring, penetration tests, vulnerability scans, and audits. And finally, we hit the risk management life cycle. We started with this, we end with this, because this is never ending. We assess, we mitigate, we manage. Whatever we find under manage, we put back into assessment and mitigation and right back around to manage again. And this also occurs, a cycle also kicks in whenever a new system is implemented or whether you upgrade an existing system. Other times that you might want to use an attack tree and do a quick risk assessment, not necessarily as deeply as this one is shown, is when a new threat emerges or when a vulnerability is announced. You want to pull out the attack trees that you have kept from your previous assessments, and you want to just walk through those attack trees to determine whether or not you need to do anything more than just note the existence of the vulnerability. Just because a vulnerability is rated as critical by Microsoft, for example, doesn't mean it's critical in your organization. Microsoft's going to throw that critical thing out there, and because it's a good way to CYA. It's also a good rating for organizations that really haven't done a lot to mitigate risk. But in an organization that has followed risk management principles and does so every day, the chances are when a critical vulnerability is released, it's going to be a low or a medium risk to your business. But it still requires a look by using attack trees and seeing how it's impacted by your existing controls. Well, that wraps up this lecture. I hope I didn't put you to sleep. And again, be sure to read all assigned reading. If you have any questions, please ask them in the main forum or in your individual forum. And have a great week.